given the head of the single linked list, reverse the list and return the reverse list. So linked list is basically nodes that are connected with each other. So in this case, 1 is connected to 2, to 3, to 4, and to 5. The structure of a linked list has a next node in the value. So the next is the pointer to the next node. So the way you solve this problem, there's quite a number of options. One is you could basically traverse and store the nodes into some array and then connect them together. You can also connect them on the fly, but the most optimal way of solving this is basically changing the link position while you're traversing. What does it mean, changing the link position while you're traversing? For example, you're given this linked list 1, 2, 3, 4, 5. Notice that you could basically just switch the pointer while you're moving to the next node. So let's say 1 to 2, you basically can point 1 to nil, and then once you move to this second node, you can just connect the second node to the previous 1 to nil. So basically you'll be tracking of the previous one, which is this is your previous in this case, right? You're connected to the previous, and then your current is this. And then you also need to keep track of the next variable. So for example, you're given this tree example here. Your next node is, assuming we started 1 and the current node is 1, right? And then the previous node is basically empty. So when you move to the next node, so the next becomes 2. You want to point your next node to keep track, so you don't lose track of the pointer here, because we're gonna change the next of the current. So the next of the current now will become the previous one, which is nil, and then the previous will now become the current, so this will become 1, and the current will become next. That's why we keep track of the next. So this will become 2, and then you go on until the next is no longer empty. So let's move to the next one. So the next move to 3. Then your current node next points to the previous one, which is 1. So this is your the next. Then the previous one now becomes the current, which is 2. And then the current becomes next, which is 3. Yeah. So basically you need to attach the current to the previous. So that's the idea here. Yeah. And then you move both of them together. So some sort of moving the previous and next together, but you need to make sure that the pointer is the next pointer is available. Like the next, you need to move next first so that you could connect the current to the next. So eventually you'll end up something like this, where your next now will end up in the nil zone, which is here on the other side of things. Yeah. So yeah, I think that's how you solve this. So let's do the coding section. So you need 3 variables, which is the var, the previous one, we just started from the nil, and then the current, which is the head, and then the next is also the head. So our condition is while the next is not equal to nil, you basically move the next to the next pointer. Then we move the current pointer, the next, attach it to the previous one. Now in this example, you'll see that 1 is now connected to nil. And then we move previous and next, the current and next together. So The previous takes the current, and the current now takes next. Yes. So eventually the next will be empty, and your previous will be the one that's gonna be the result. So let's run it out. It should be equal actually, because we already initialized it. Yep. So this is how you optimally solve this problem. The time complexity is O of n, where n is the number of nodes, and the space complexity is basically it's constant. We didn't use any space, we just used the same nodes. So yes, this is how you solve this reverse linked list. If you like this video, please hit like and subscribe, and we'll see you again in the next episode of LeetCoding. Thank you for watching.